Hi everybody, this lesson today is going to talk about special cases of systems of equations. So we've been talking about substitution method and elimination method, and we did graphing also. And this is not going to be anything new as far as those methods go, but it's going to be certain cases that happen from time to time. So there are three different cases. If you have two lines, you have some options. If you have two lines, they might hit each other, or they might be parallel to each other, or it might actually be the same line. So that's what we're talking about, is like, what are the three possibilities? If they intersect, this is all that we've done so far. Everything we've done so far has been intersecting. That means that they have a normal answer, like x equals 3 or y equals 5 or whatever. But sometimes when we do it, we're going to get some lines that are parallel to each other. And remember that when we talked about the solution is where they hit. Okay, well, if they never hit each other, then there is no solution. And so we just say as our answer, no solution. Sometimes, though, we have this situation where we have two lines that end up being the exact same line. Like the equations look different, but in actuality, it's really the same line. And if that's true, then we have infinitely many solutions, because there's like a point here, a point here, a point here, a point here. Like everywhere that they hit is a solution. There's a bunch of them. So what we're going to find is, if we're trying to do an algebra problem and we're working with it and it is a no solution problem, it's giving us parallel lines, then when we work it through, it's going to give us nonsense answers, something like 0 equals 5. If we get something like that, that means no solution. But if it's the same line, it's just kind of in disguise, but it really is the same line, then we're going to get something really obvious, like 7 equals 7 or 10 equals 10 or whatever. So let's work through some examples. This first set is asking us to use substitution, so we will, because they're asking us to do it that way. This one, x equals, here is an x, and so we're going to plug it in. I'm going to take that bottom equation, and I'm going to plug in for my x. So I'm going to plug in y plus 1 into those parentheses. Now, I don't know if you've ever learned this. I know you have learned it. I don't know if you remember it. When there's a negative outside, you actually have to distribute that negative sign. And a lot of people forget to do that because you're subtracting the whole thing. So it's like a negative y and a negative 1, or you could say plus negative 1. And then you have plus y, and then you have equals 2. All right, if we focus on the left-hand side of the equation, we have a negative y and we have a positive y. Negative y and positive y added up, they add up to 0. So what we have here is 0 plus negative 1 is equal to 2. Is that true? No, that's nonsense. If it is something like that, something that does not make any sense, that means there is no solution. That means that if we went to graph these, they would be parallel lines. Let's look at the next example. Okay, we're going to use substitution again. Here's my y. I'm going to plug in for this y. So I'm going to take my bottom equation, and I'm going to plug in, and I'm going to plug in 2x plus 1. Now, once again, I have this negative outside. If I have a negative outside, I have to distribute it. So it's going to give me 2x minus 2x, and then negative 1 is equal to negative 1. 2x minus 2x is 0, so that drops off. I have a negative 1 equals negative 1. Well, yes, it does, obviously. So this is an obvious answer. That means it is many solutions. What that means is, if we went to graph these, they're actually the same line. And they may not look like it right here, but we can see there's some similarities. There's a y, there's a 2x, there's a 1. Like, they're not exactly the same, but to graph them, actually, they would be exactly the same. So that's what happens when you are working out a problem with substitution. What you really want to focus in on is, at the very end, if you get this strange answer, like x's are all gone, y's are all gone, we don't have anything, negative 1 equals 2, no it doesn't, that's nonsense, that's a no solution. Or down here, negative 1 equals negative 1, no, that means it's many solutions. Okay, because yes, obviously negative 1 does equal negative 1. But the x's are gone, the y's are gone. All right, let's look at how about elimination method. All right, elimination method, remember, that's when we add them together and we just add them straight down. So if I add these two equations straight down, negative 7x plus 7x, that would be 0. Y and a negative y, that would be 0. Negative 2 and 2, that would be 0. I end up with 0 equals 0. Obviously, yes, 0 does equal 0. That means there are many solutions. And if there's many solutions, that means they're actually the same line. Sometimes people say infinite solutions, but I want to make sure that you know it's not infinite like every number in the whole world. It's just infinite because on that line there's infinite points. Let me show you again on our diagram. So we have this. It's like all of the points on this line are the answers. There's an infinite number of points on that line. So you could say infinite. I just like to say many because I think it's less confusing. Okay, still doing elimination method. If I look here, can I do elimination method? Well, I can if I multiply by negative 1. Or some people just end up subtracting those equations, and that's fine too. But I'm going to go ahead and multiply by negative 1. So my top equation does not change at all. My bottom equation, I was not really paying attention. If I want to do elimination method, I have to multiply this by negative 2, not negative 1. All right, let's multiply by negative 2 instead. So that gives us a positive 2x, a negative 2y, and a negative 6. So I'm going to add these straight down. Negative 2x, positive 2x drops off. Negative 2y, positive 2y, and negative 2y drops off. And here we have a negative 4. Does 0 equals negative 4? No, that's nonsense. If it's nonsense, we say it's no solution. That means if we did graph these, they would be parallel lines. Okay, that's all we have to know for today. It's just the same stuff with multiplying or elimination and substitution, but it's just when you get to the end, what kind of an answer do you have at the end? If it's a really obvious answer, like two things that equal each other, then that is many solutions. If it is a lie, then that is no solutions. And that's it. All right, we'll practice this in class next time.